You know, we think of mathematics as this solid rock, right? It's the one place where we can find absolute, unshakable truth. It's the language of the universe. But what if that rock, that whole foundation, was actually built on sand? Well, that's exactly the question that sparked a massive crisis right in the heart of logic, and today we're going to dive right in.
So, just for a second, imagine this. What if a mathematician, following every single rule of logic perfectly, could prove that 1 equals 0? I know, it sounds completely absurd, but this very question is what nearly brought the entire field of mathematics to its knees. Because, look, if you can prove that, you can prove absolutely anything. And the whole idea of truth just collapses into meaninglessness.
And seriously, that is not an exaggeration. About 100 years back, a crack appeared in the very foundation of mathematics, a crisis so deep that it forced the smartest people on the planet to completely rethink what it even means for something to be true.
All right, Section 1, a foundation of certainty. To really get how shocking this crisis was, we have to go back and understand the mindset before it all happened. This was a time when math was seen as the one true source of certainty in the world.
People pretty much believed that mathematicians were like cartographers of reality itself. They were charting this single, flawless map of the universe. And on this map, every single statement, every idea had a precise location. It was either true or it was false. There was no gray area, no maybe. It was this perfect black and white world of absolute certainty.
So what happened? Well, someone found a place that just wasn't on the map. In fact, it was a place that proved the map itself was fundamentally broken. And this whole thing started with a ridiculously simple idea, the concept of a set.
So what's a set? It's literally just a collection of things. I mean, you can have a set of teacups, a set of all the even numbers. You can even have a set that contains other sets. It's about as basic a building block as you can get in math. What could possibly go wrong with that? Well, as the philosopher Bertrand Russell was about to find out, a whole lot.
Okay, you gotta follow this logic closely, because it is a real mind bender. Russell came up with this idea for a special kind of set. Let's call it R for Russell. R is the set of all sets that do not contain themselves. Now, most sets are like this, right? The set of all spoons isn't a spoon itself, so it would belong in R. But then, Russell asked the killer question you see right here. Does our special set, R, contain itself? Well, let's think about it. If it does contain itself, it has to follow the rule. But the rule says it can only contain sets that don't contain themselves, so it can't be a member. Okay, so what if it doesn't contain itself? Well, then it fits the rule perfectly, which means it must be a member.
So, it has to be a member if and only if it is not a member. The logic just eats its own tail. This wasn't some fun little brain teaser. This was a fundamental breakdown of the entire system. That perfect map of reality suddenly had a giant, gaping black hole right in the middle of it.
So, you might be wondering, why was this one little paradox such a catastrophe? Why not just say, okay, weird, don't make that set, and just move on? Well, it's because of what a single contradiction does to a logical system. It's not just a little error, it's a logic bomb. In the world of classical logic, if you can prove just one single falsehood, you get the power to prove literally anything and everything. The whole system detonates.
There's actually a formal name for this, the principle of explosion, ex falso sequitur quod libet. From a falsehood, anything follows. It means that if you can prove that Russell's paradox is both true and not true, you can then logically prove that the sky is made of cheese, that 1 equals 0, that unicorns are real. Everything becomes provable, which means nothing is true. The entire structure of math would be built on absolutely nothing.
This crisis forced this massive, profound realization. The foundations of math, they weren't like laws of physics just waiting to be discovered. Nope, they had to be chosen. Rebuilding meant they had to start making philosophical decisions about the actual rules of the game. And this, right here, is the absolute crux of it all. The dream of one single perfect, absolute justification for math was over. Truth, as it turned out, was relative. It's relative to the foundational axioms, the starting rules that you decide to begin with. Your justification for what you believe depends entirely on the system you choose to believe in. And so, that single black and white world of logic just shattered into this whole spectrum of what you could call colored logics. You had some mathematicians, the formalists, who basically tried to patch up the old system.
They added new rules, new axioms to try and outlaw these paradoxes. But then you had others, the intuitionists, who were total revolutionaries. They said we needed a much more radical solution.
So that brings us to the intuitionists. They came forward with this genuinely revolutionary idea. They asked, what if truth isn't something we discover out there in the universe? What if it's something that we actually create inside our own minds?
I mean, just look at the contrast on this slide. Classical logic says a statement is true or false, whether we can ever prove it or not. The truth is just out there. But the intuitionists said, no way. For them, a mathematical statement is only true if you can actually provide a direct, constructive proof for it. Truth doesn't exist until you build it.
And this led them to throw out one of the cornerstones of all classical logic, the idea that every statement has to be either true or false. They said, no, there's a third option. As you can see here, a statement could be proven true, or it could be proven false, or it could be in this middle ground of not yet constructed, just waiting for a proof that might never, ever come.
So where does all this leave us today? Let's go back to that map metaphor one last time to wrap this all up.
We started this whole story with just one map, right? A single universal map that everybody believed was a perfect one-to-one representation of reality. It was comforting, it was certain.
And Russell's paradox? That was the moment we realized we could sail right off the edge of our trusted map into total nonsense. The territory it described wasn't complete. In fact, it was impossible. The map was fundamentally flawed.
The only way forward was to become better map makers. Instead of one map for everything, mathematicians created an entire atlas of new specialized maps. Different logical systems, like intuitionism or modern set theory, each one designed for a specific purpose, each one useful in its own right.
And that really is the ultimate lesson here. Yet we lost that feeling of absolute certainty, but we gained something much deeper. There is no single God's eye view map. The truth of any statement, its justification, is always, always relative to the map, the logical system that you choose to use.
So, I'll leave you with this thought. If even mathematics, the purest form of logic we have, ultimately rests on a foundation of human choice, it kind of makes you wonder, doesn't it? What about all the other truths we build our lives on? What maps are we using without even realizing it?